So my name is Davrondzhon. I work as a technical test analyst at Norsk Helsenet, focusing on test automation and security testing. And today, Norsk Helsenet is, you probably some of you heard about Norsk Helsenet yesterday. There was two presentations from Norsk Helsenet. And Norsk Helsenet is a state-owned company with about 1,000 employees. And we develop and maintain electronic health services in Norway, among other tasks that Norsk Helsenet does. And today I'll be talking about one of the products that we develop and maintain in Norway. And I'll be talking about visualization for effective testing and learning in the context of this product. Okay. But before I jump to tell you about the cases or visualization cases that we have applied when we were testing, just as a wise man said, to try to answer the fundamental question, why we need effective testing. Right? It was also asked in the morning session. It was formulated, do we need the testing? Okay? Why we need effective testing or testing at all? So let's try to see what happens if we don't test, or if we don't test it, if we test it improperly or ineffectively. So one example is NASA's orbiter, which was lost due to a simple mistake, which afterwards appeared to be a simple mistake. So NASA is a complex system, and it consists of many components, and the components were developed by different teams. And one team, they used in their calculations, they used English unit metrics, and another team used ISO, or standard unit metrics. And when the data was transferred from one component to another component, and there was a mismatch, and kaboom, 120 US dollar of taxpayers was gone. Okay, so it's very simple mistake, but it cost a lot of money. And another example, which was also mentioned today, is Knight Capital. So it's a financial firm that lost almost $500 million in less than 1 hour. Okay, they bought a new software, and they put it on production, and the first hour, so they lost almost $500 million. And the mistake was due to they had a flag in the software. In the software, they had a functionality that buys and sells shares very fast. And this functionality shouldn't be put in production, and they had a flag, and that flag was not turned on. So this also cost $500 million, but it was not money of taxpayers. Okay. And maybe a bit more ugly example also is, or bad example is that Terak 25 machine. So it's a radiation machine which is used for treatment of cancer. The machine machine had worked fine in many cases, but there was some cases when operator could make a mistake, and this combination of mistakes, they resulted in a race condition, and it in its turn it made that, for example, this machine, it increased dose of radiation maybe 100 times, more than 100 times, and report indicates that it was related to 6 deaths of the patients. This example may be a bit late, but recently, this year and last year, also Tesla, they recalled cars due to software errors. So one can find many such examples of causing a lot of money, or maybe in some cases death of people due to software error. Okay. But the question is why such error happens. Okay. I believe it's not because of lack of testing. Maybe some of these systems were tested quite extensively, but maybe because of a lack of ineffective testing. Okay. So I have one question to the audience. Do you trust your team's code? Okay. My original question was that, do you trust your own code? But I thought maybe it's a bit stupid because everyone trusts his own code, right? Otherwise, what's the point of to write code? So those who think they trust their team's code, can they raise hand? Three, okay. 4 or 5 people trust their team's code. But then I again question, do you really trust your team's code? Or you think you trust? Okay, one really trust, okay. Let's see. I'll just show some clip and see if you, maybe next time if you want to trust your team's code, you can think about it. I think this guy wrote, I'm not sure, he wrote software that controls this machine, and he's testing it with his own head. So if you trust your team's code like this, then yeah, probably the world will be fine. But it's you can think one more time if how much trust you put. Yes. So we said, okay, we need more effective testing, right? So first, let's look into how we design tests. Okay, how usually we design tests is that we have a list of user stories or requirements, or what do you call it, and we read these requirements, and we think we understand them. And based on our understanding, we create tests. Okay, we do magic and we create the test cases, for example. And this is we often do, and I think your testers also go this way. And I think you also, when you write code, you also base your code on user stories. And most of the user story is textual information, right? What we propose is sometimes maybe it's more effective to design tests not directly from textual information, but from a graphical representation of the system under test. Okay? And there are at least 2 benefits with this approach. First one is drawings. It can be basis for a discussion between, for example, tester, developer, product owner, many other roles in the team. So it adds an extra layer of quality assurance in the process. And the second one is once we get a graphical representation of system under test, we can extract the test kind of mechanically, easily. And we don't have, maybe we don't have to do much intellectual thinking once we have this graphical representation of system under test. And speaking of the thinking, this thinking is a core topic of psychology, and probably there are many books, good books about this the topic. But one of them is Thinking Fast and Slow, and it says that humans, we think in 2 modes: System 1 and System 2. System 1 is fast, automatic, and intuitive thinking. For example, 2 times 2 is 4, and System 2 is more deep, slow thinking. So when we are creating a graphical representation, so we are kind of employing System 2, and when we are with a high cognitive load, and when we are creating tests, or when we are extracting tests from drawing, then we are employing System 1 with a low cognitive load that I'll show soon the cases. So our system on a test is helsenorge.no. So helsenorge.no is a national portal for e-health services in Norway. It consists of two parts. First one is an open part, which contains general information about diseases, patient rights, for example, tips and recommendations for healthy life, training, food, and so on. And the second part is a closed one, or which requires authentication. Okay, when you log into the helsenorge, to the portal, then you will see the list of your services that you can use via helsenorge. For example, you can send and receive messages from a GP, from your doctor. You can confirm or cancel doctor appointments. You can check result of your medical result. For example, corona. You can check your corona test. You can become a donor by a couple of clicks via helsenorge. And in this year, beginning of this year, number of users has reached 5 million. Number of users of the portal is 5 million. Just to put this number into perspective, population of Norway is about or less than 5.5. So 90% of the population are users of the portal. It's partly it was partly due to corona situations that we had last 2 years. Sorry. So also a number of logins last year, it was 77 million and 140 million website visits. Okay. You can think, okay, well, what's a big deal with this number? But if we say that one telephone call to the doctor is equivalent to 10 logins, and one physical visit to the doctor is equivalent to 100 or maybe 1,000 logins, then you can easily convert this number into saved time and money. And a visualization or a drawing that we have applied during testing, we applied in 2 cases. So let's start with the first one. It's testing GDPR. GDPR, it stands for General Data Protection Regulation. And if you remember, in year 2018, the main topic of IT news, it was GDPR. Almost all the company and organizations, they modified or updated their consent and privacy documentation to be compatible with GDPR. And so did we in the portal or helsenorge. Okay, before GDPR, in the helsenorge, we had a kind of yes or no, or agree or not agree consent. But after GDPR, so we have 3 levels of consent. Okay, and you may ask why we need 3 levels, because it's to give a user flexibility. And one of the purposes of the GDPR is to put a user more active role in the management of his data. So when we have 3 levels of consent, so it gives a flexibility to user, because some people are maybe more optimistic about having their health information in the internet, and others are more conservative. So depending on their needs, so they can choose which level the user wants. Okay, this is an example of, for example, a user with 3 consent level. So full, basis plus, and basis. So when user has a consent level full, so he has access to all the services in the portal. Okay. When user has access to the basis plus, so she has to smaller number of services. And when she has a consent level basis, so she has to lowest number of services. The difference between basis plus and basis, there's a one tile less in a basis. So users who are basis, they do not have access to the patient journal or patient records. So how so our task was to test this functionality. So how we tested it, or how we developed a graphical representation or visualization of this functionality. So we said we just draw 3 circles for these 3 levels. We call it as full, as basis plus, and basis. Right? And now we can see all the users of the portal, they are in one of these circles. Okay, I'm also in one of these circles. I'm a user of the portal. And we need one more circle. Let's call it S0. And we said that this is all the users who are not in the portal, they are in S0. So now we can see that all the people in Norway, they are in one of these circles, or states. It's called also maybe states. And those who are not who are not using portal, so they can consent, they can give their consent and start using it. For example, they consent to the basis, and they can change it to basis plus and full. And in the same way, so they can downgrade their consent level. So this is a little visualization of the functionality of giving and changing consent. But we can ask, okay, when this is happening, okay, when change will happen. For example, when user goes, for example, from basis to basis plus, okay, when this happen, when this will happen. It will happen, for example, users will select the basis plus in the window and click, for example, next, and maybe come up another window, and which confirmation window, and he clicks OK, and then it will be his consent level will be changed. Okay, there's several steps, and there's several information, textual information, but we say, okay, we cannot put all this information in the picture, right? So we say it's user goes from basis to basis plus when there's a 2. So I'll say soon what does this mean, number. And we need numbers for all these arrows, for all this transition. So if there's when user has consent level full, and when there's a 2, so he goes to S basis plus. Okay. So if you look closer, what does it mean? What does this picture mean? For example, going from S full to S from S full to S basis plus. It means actually it's calling an API. In this case, it's called set article level with parameter 2. So all these arrows and all this transition, it's calling an API with the parameters. So 0, 1, 2, 3 are parameter to this API. So here we are just focusing on the core functionality. So we are, for example, when this functionality was implemented, there was many user stories, for example, talking about the button colors, fonts, and so on. But we are focusing on the core functionality. It's this API. Again, this is the same picture, but I call it now as S1, 2, 3 instead of S basis, basis plus, and S full. And we said that this is a kind of a positive picture or positive model of the functionality, because I said that arrows, it means they're calling API with valid input, but we can call API with invalid input. Okay. For example, this is E indicates the API calling API with invalid input. For example, if we call API with 4, 5, or so on, so we are expecting to receive an error message. For example, technical error and so on. And you may ask also, here we said that 0, 1, 2, 3 is a valid input to API. But here, for example, we are having also 2. But one thing also, the black arrows, it means that positive, we are, for example, when we are calling API, we are verifying that HTTP response to 200 or OK. And when we are calling API, for example, with this with invalid, so we are verifying error message. And red ones is we are verifying error messages. And here I said that 2 is valid, but we are calling API with the invalid context. So it means that once you gave your something, once you gave your constant level to basis plus, you cannot do it twice. Okay. Otherwise, if it's possible to do it twice, so you can manipulate the date time step. So this is small graphical representation of something of constant level in helsenorge. But as I said, the goal was to develop this drawing to extract tests. Okay, and let's say if our criteria is to test all the transition or all the edges from this picture, then we can enumerate it like this. For example, if user here S0, when the input 1, it comes to S1. So this is the first case. Okay, and then we have 12 cases. We need 12 tests to have 100% edge coverage, or to test all the possible combination of API call. And this is, of course, this is abstract cases. I'll show concrete cases also, test cases. Another aspect of this portal that I mentioned is that users can use portal not only on their own behalf, but also on behalf of another person. For example, let's say an old parent, she can authorize usage of portal to her adult son. Okay, and portal provides functionality for this one. And the services in the portal, they are grouped into 3 areas. So-called portal is Norwegian, in Norwegian, so it's maybe difficult to read here. This is a 3 authorization area that one user can authorize to another. So user can click, for example, here, can make choices and click OK to create an authorization, which gives access to her medical and health information to another person. So this is a window for giving. So how we also drew graphical representation for this testing or for this functionality. And authorization, it depends from on the constant level. Okay? That's why I have this picture again. So this is a changing authorization. Again, I said that there is 3 authorization area in the portal, and I call it F8, F9, and F10. And user who has a constant level basis, S basis, so she can authorize to this F8 area to another person. Right? And user who has a constant level S basis plus, so she can authorize to F9 and F8. And users who has S full, so she can authorize all the 3. This is these arrows again. As I said previously, it's calling an API, and we need the inputs, right? And users which are in S, for example, S basis, they cannot authorize to the area F10. Okay. So if they attempt to do it, so there should occur an error, for example, technical error. And in a similar way, which if a user has a constant level at basis, so she cannot authorize to F8 and F10. The whole point with this picture is that you cannot give access to more information or to more services than you have yourself. Okay. Services at S basis is almost equivalent to the F8, and S basis plus is equivalent F9, and S full equivalent to S10. So you cannot give access to more information than you have yourself. So this picture is saying this one. Okay, if a user attempts it, so we are expecting to happen a technical error or some kind of error message. So again, if we say it, this is calling an API. In this case, it's called create full mapped with the parameter 10. And we verify that, for example, status code are 200 or okay. This is the same picture. with a, yeah, I drew it with another tool. But now we have one more state, so-called F0. It means that I said that API can be called with a valid input and API can be called with invalid input. Here F, the symbol F, it means that we are calling API with invalid input. And valid input to this API was 8, 9, 10. And if we call with 11, 12 or ABC, so we should expect that there should be some error and authorization is not created. F0, it means that no authorization. And again, the purpose of creating a picture or graphical representation is set to extract tests. So again, if we say that our criteria is to test all the possible combination of calling API, for example, all the possible all the errors, then we need 12 cases. So if we are here, for example, S3, when there is a 10, we end up here. Okay, S3. This corresponds to test 6. S3 and when it's 10, so we end up F10. So we need we need 12 cases, and for first 6 one is we are verifying, for example, 200 HTTP response, and for the last 6 ones we are verifying some kind of error message. So this is once authorization is created, so it can be updated, right? You don't have to understand this picture, but if you remember in the previous drawings, I used two colors. It was black and red. Black is when the response is okay, 200, and the red is when the response is error. Yeah, for example, some kind of error message other than 200. But here I'm using blue, for example, color blue, this one, which means that going from F9 to F10 when we are updating, it depends not only on the current circle or not on the current state, but also on the previous state. For example, if you came to F9 from S3, then you can update it to F10. But if you came, so it will be black. If you came to F9 from S2, from here, then you cannot go it up. So it will be red. For this picture, we need a pair of edges, not only one edge, but pair of edges. And then we have 24 tests. So we have 24 tests. You can look into it offline. Yes, it was short about the testing GDPR or GDPR. And the second case where we have applied this graphical representation of system and test when we were testing access control. Okay, the question again, why we need a more rigorous approach to testing access control. First one is portal. It deals with health and medical information, which is sensitive and critical. And the second one is failures or errors related to access control. Is number one is in OWASP top 10. So OWASP top 10 is a collection of security errors, and they sort it which type of errors coming often or occurring often, and errors related to access control is occurs of all other security errors. So we need a bit more rigorous approach to testing access control. And the classical example of access control is if we take an IT system, it's role-based access control. If you, for example, IT system in health, in the hospital, so you have roles for a doctor, surgeon, nurse, radiologist, and so on. But the role-based access control is not scalable when number of users, hundreds of thousands or millions of users. So another approach is to use attributes or attribute-based access control. And Portal, it implements attribute-based access control, which means that access is granted or denied based on user's attribute. And one of the attributes is a constant level that we have seen so far. So which can be full, basis plus, or basis. And another attribute is address type. Some people in Norway, they need protection, so they have a confidential address. So address type, it has two values, ordinary and confidential. Another one is age group. Okay, portal can be used also on behalf of children. So we have 3 age group: adults, which are older than 16 years old, and children who are from 0 to 11 years old, and children who is from 12 to 16 years old. And there's several other attributes which influence access control. And access control is granting and denying access to the services. What's a service? Service for the end user is, for example, sending and receiving message to the doctor. And how it does it, for example, he logs into the portal, he goes to some web pages, he clicks on the buttons and so on. But for us, let's think about the service as an API. Okay, so it's giving access to APIs. And one example is that 2 years ago, so when Corona pandemic came, so we get a request to implement services related to Corona, and this request was formulated in terms of about 73 user stories, and our development teams, so they implemented or transferred this 73 textual information into 4 APIs. For example, print Corona certificate, show Corona certificate, get Corona certificate, and so on. Let's call it API 1, 2, 3, 4. And we draw one API as one black circle. So 4 black circles, which are APIs related to Corona certificate. But portal is not the only Corona certificate, as I said. It has user can, for example, it has many APIs. For example, sending, receiving message from the doctor, confirming doctor appointments, renewing prescription, becoming a donor, and so on. So I'm not sure about the exact number of APIs in the portal. I think we have a few hundred APIs. And when user logs into the portal, she has access to all the APIs. Given that she has a constant level full. But if she has a constant level basis plus or basis, so she has access to a smaller number of services. But if you say if user has a confidential address, so she has access to another group of services. Okay? So this red one, for example, if user has a confidential address. So this is kind of also a picture of access control, also portal. But you probably agree with me that this is difficult to remember and unstructured, and more importantly, we are not sure how we can use it to extract tests from this picture. So we try to draw it a bit in a more structured way. So user logs in to the portal, and portal checks if she has a confidential address. No. Then checks which constant level, or it's called here a privacy level, but it's constant level user has, basis plus, or full. And whether user has a patient journal or patient record available via portal. By default, patient journal is available, but user can change it. So user can remove this link to her patient record from the portal. So outcome yes, no. And whether user has access to Sharn journal. So Sharn journal is also a kind of journal, medical journal, that contains some important health information about the user. For example, severe disease or severe allergy or implants user has, and so on. So the difference between patient journal or Sharn journal is that patient journal is kind of it's a hospital. Let's call it responsibility of hospital, but Sharn journal is a national journal. So, and the purpose of Sharn journal to have it national is to have a fast access such that health personnel can have fast access to the more important, to critical information about the patient. So this information also, Sharjuna is also available from, by default it's available at the portal, but user can change it. So we check if it is, if she has available her Sharjuna on the portal, yes, no. And at the end, user is granted access to a group of the services. For example, if user ends here, so it's a, we call it a scope. This scope, it's a grouping of services that user has access to. Okay? And this picture when a user has, when user does have a confidential address. Okay? As you can see, users who has a confidential address, they don't have access to Sharon Journal. So all the outcome is no, no, no. And so with four, now we have 4 attributes: address type, consent level, Sharon Journal, and patient journal and Sharon Journal. So these 4 attributes, we end up with 15 scope, or 15, yes, user will end up in one of these 15 scopes, or 15 leaves. Okay. So again, the purpose of drawing is to extract tests. When we are testing access control, actually we are testing 2 types of tests. First one is verifying verifying presence of access, and second one is verifying absence of access. Okay, for the first one, so we can we need 15 tests. So we can now, our test is like this: you, no, basis, no, yes. It means that we start from the root of the tree and we travel to the each leaf and enumerate the name of edges. For example, you, no, basis, no, yes. So to test all the possible combinations, so we need 15 tests. Let's call it 15. We need 15 users with combination of attributes. And this is for verifying first type of testing, verifying presence of access. So we log in here, for example, and we check that user has access to all the services. When testing a second type of test, yes, verifying absence of access. So we have to look into pair of scope, not just one, but pair. So I'll soon say why. Because, and we said that for the first one we have 15 tests, and for the second one, when we are looking into pair, so we end up, we need 105 tests if we want to 100% coverage. It means the first one and second one, first one and third one, first one and fourth one, and so on. And then we start from second one and third one, second one, fourth one, and so on. So we have we need 105 tests. And from a security perspective, second type of testing is, has more criticality. And we think that the first type of testing is more or less is covered by functional testing, ordinary functional testing. And first one is kind of positive testing, and second one is negative testing. I said for the second one, we have to look into pairs. So let's look closer into one pair. For example, between this one and this pair, which is number 76, this one. So instead of cryptic U basis no, 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 I just said, okay, this is user 1 and user 2. As you can see, user 1 has access to all the services of the user 2 and 4 extra. So this green ones, green APIs, is only accessible to the user 1, but not to user 2. So how we test it? We log in as a user 2, and we try, or we attempt to access prohibited APIs. And we verify that we get an error message, for example, access denied. So this is one pair, and we need 105 pairs. So this is an abstract picture of test, one test. But this abstract is also converted to concrete test case. This is a concrete test case that implements this abstract case. For example, we log in as a user with a user ID. We set necessary privacy level, it's in this case full, and we visit pages, or in this it can be, we are calling API, for example. And services, and the value of the services is this ones: patient, browser, symptom, critics, info, challenge, and so on. So this 4 is equivalent to this 4. And in step 5, we are verifying that error message. That we get an error message, you don't have a permission to this service. So this is a concrete test case that implements this case. Very briefly about also this this test case. It's automated test case. It's not manual. Very briefly about our automation approach. Our automation approach is BBD. It's a behavior-driven development. But I'm not going to too much detail on our automation approach because it needs a separate session. So this is an example of our automated test case. All our test case is in Norwegian, but as you can see, this is a kind of structured text, which is understandable to the tester who does not have a technical background or who cannot write a code, but who has a domain knowledge, so she can understand the test case and she can update input or test data and so on. So this updating she can do. And behind each of the cases, behind each of the test steps, there's a code which makes it to run automatically. So this is a kind of this is a test code or test C# class, which implements this step. So this is I'm just showing you code since to make it complete. We are in development conference. I saw many codes, so it's probably to make it complete. So I just showing. So this is implementing this test step, and for each of them we have such a code. Okay, back to our test access control tree. So this is the access control tree that we have seen, right? And this access control tree, it has only 4 attributes. Okay. A more realistic access control tree that we have developed is this one, which has more attributes. It has 7 attributes. And the tree that I have shown you before, it was just this part. Okay, just this part. And I said that portal can be used also on behalf of the children if they are between 0 and 11 years old, this part. And when the children is between 12 and 16 years, this part. And this part is when you are giving us, when you are authorizing another person to use a portal on your behalf. So this there was a 3 authorization area, and this 3 authorization area, it will end up in if you take all the possible combination, it will be 11. I think it's 11. So this is when portal being used on behalf of another person. Okay. And the scopes or leaves which are connected with the lines, it means that we are tests that implement this scenario. So we have a test that covers this scenario, and we have around 700 automated tests. And most of this test goes to access control. Okay, testing. Most of them goes to the second type of access. Second type of testing access control. That's verifying absence of access. Okay. That's why we have to look into pair of scopes. One question you may ask that if you are if you are a developer, for example, I said why we need to look into pair of scope. Not, for example, you can log in one scope and you can just try to access all the other API which are not allowed. Why we cannot do it? Because when we are calling, when we are doing like this, so we are calling, we will get error anyway, but this is error because of we are calling API with the wrong context. Okay, That's why we cannot do it like this. So you have to have a correct context to call an API. So that's why we have to look into pairs of scope, not, for example, to log in you log in for one and try to access all of possible APIs. It's not impossible. So this is a picture of kind of abstract picture, right? And to relate it to physical world, let's say we have a user called Ola Norman, which is 44 years old, and he has a daughter of 12 years old. And we assume that Ola Norman, he wants to use a portal, all the services on the portal, and when he logs in, so he will end up here. Okay, and when he wants to use a portal on behalf of her daughter, so he will end up here. So this 7 attribute, it will give us a 66 scope. If you want to test all of them, so we need a 66 kind of a user with different combination. And when we are looking, this is for the first time and for the first type of testing. And if we are looking into pairs, so it will result in more than 2,000 of pairs. So 66, it will result in more than 2,000. So it's short about how we developed a graphical representation of system on a test, and we extract tests from there. And one benefit, or once we are when we are testing, so we have to answer one question. Okay, what's the test coverage? It's whether it's 50%, 60%, 100%, or some subjective evaluation like low, high, medium, and so on. But when we have a graphical representation of system under test, we cannot we not only answer to what's the question, what's the coverage, but we can also answer to where's the coverage, so we can see the coverage. Right? So, for example, we have a coverage here, but we don't have coverage here. So we can see where. Also, it's sometimes it's maybe more important to know where we don't have a coverage. So if you, for example, if we have many tests, some of tests are maybe low criticality, and if we run all of them, maybe it will influence test coverage. But when we have a graphical representation, we can see where we have a coverage, test coverage. So here we have, and here is the same picture, but I put, for example, here it's a small, but ATC, it's a number of test cases that implements this scenario. Okay, so you can see where the coverage is. Not only what's the coverage, but where coverage is. So if you think drawing can be also useful, if you want to try it, my best tip is try with a pen or paper. And once you get a nice picture on the paper or on the whiteboard, then you can probably think about finding some tools to draw it better. So if you have to remember one slide, so this is the slide. So sometimes it's more effective to design tests not directly from textual representation, but from a graphical representation of the system on the test. And the message is that we have this a figure replace 100 user stories. And if you are also interested in more details, so we have published papers in peer-reviewed academic conferences about these two cases, and also about test automation. So these papers, let me know if I can give a copy of them. So thank you very much for your attention, and if you have questions now or next, I'm here today, also tomorrow. So thanks.